The overall goal of this experiment is to provide a greener methodology for a common esterification reaction, which could serve useful for ester synthesis in academic and industrial applications. Our method can be used for efficient and mild synthesis of esters by coupling carboxylic acids with primary or secondary alcohols or phenols. The main advantage of this technique is that it eliminates the use of hazardous chlorinated or amide reaction solvents and minimizes solvent waste during purification without sacrificing reaction rate or product purity. Demonstrating the procedure will be Andrew Lutjen and Mackenzie Quirk, undergraduate researchers from my laboratory.
First, combine tranexamic acid, DMAP, and EDC in a 50 milliliter round bottom flask. Add 15 milliliters of acetonitrile and 98 microliters of 3-methoxybenzyl alcohol to the mixture, along with a magnetic stir bar. Clamp the flask in a 40 degrees Celsius water bath and stir the reaction. Monitor the reaction by TLC using ethyl acetate and hexanes. Once the reaction is complete, remove the acetonitrile under reduced pressure using a rotary evaporator to obtain a crude solid. To the residue, add 20 milliliters each of diethyl ether and 1 molar of hydrochloric acid. Swirl the flask to dissolve the residue into the solvent layers. Next, pour the solution into a separatory funnel. Rinse the evaporating flask with 5 milliliters of diethyl ether and add the rinse to the separatory funnel.